Alright, everybody, welcome back to Polynomial Madness. And today we're going to be exploring into the world of uh, multiplying and dividing polynomial examples, or monomials rather. Right, so on the first shot we have ax plus b is actually times b when it is times. For some of you who may not know yet, but this dot in the air after ax is actually the multiplication symbol, which, as you know, it's really confusing when you put it with the x's. So we get a times b plus a plus x, which is a which is pretty easy because you can swap them around anyhow. I don't care what the rule names are, but whatever. Let's continue to the next example. So ax times bx is equal to ab times x squared. And the next is ab times, actually it's ay times bx is equal to ab times xy. Alright, now on to division. So a over b, ax over b is equal to a over b times x, and ax over bx is equal to a over b. Since x to the first power times x to the negative 1 is equal to x to the 0, which is 1. And there we go. Proof of x to the 0 is equal to 1. Pretty simple. And it's like the last example, a y over bx is equal to a over b times the variable x over y over x, sorry. Right. So we have some laws about brackets. So we have a, because this, let me talk about something beforehand. So this law is very, very important. You hear me? This is way too important to not know, because this law here can affect your calculations, such as we have a plus b, or positive b, is equal to a plus b. Sorry, there's a little bit of talking in the background. Never mind. Please forgive me for that. So a minus positive b, or plus b, is equal to a minus b. You might know this already. So there is a little bit of technical problem. I didn't check whether we reached this point or what, because this screen recorder like software has had a problem. So let's continue. And we have minus b, which is a minus b again. So someone may not know this already. And we have a, this is surprisingly a plus b if you haven't already known algebra for a while. So it's negative times negative is positive, and always, yeah, whatever. Right, let's continue to the next part, which is about polynomials, actual polynomials. As suppose we have x plus y, all of it times y. We already learned we didn't learn any of that. Who cares anyhow? So we have x plus y times y, all of it times y. We have xy plus y squared, right? Then what if we have x plus y squared, or times itself, like x plus y? So how would you approach this problem? Well, it took when I was a student and I was still 12, now I'm 13, I can't do this whatsoever. So there's a quick way to do this. So we just do this, do the same thing, plus xy, and then we add by y times x and xy plus y squared. So we have x squared plus xy plus y squared. No, actually 2xy. I got that wrong. Sorry. Right. So that is the very, very foundation of polynomials. Alright. So we are going to explore about polynomials, and we're gonna have to show. Kidding, I'm not trying to end the episode here. What the hell am I doing? God, my brain today. Right, so I think I've been in so much stress today. So what if we have x minus y and squared? So how do you do this? How do you approach this thing? We have x squared minus x y, and then we add by negative xy, and this, we don't need this thing because we already know in the preceding moments before we did this, we have negative xy plus negative, so y squared. So we have x squared plus, no, dang it, x squared minus 2xy plus y squared. Not simple enough, right? We have then the next two binomials that are going to be multiplying each other. This is kind of weird. So x minus y. Alright, this is familiar. You might think so, but we have x plus y. I suggest you pause the episode and try to find out. Alright, I think you paused the episode, so we have x squared minus xy plus xyx, or xy is the same anyhow, plus y squared. So we have x, not minus, plus minus x squared minus y squared, and this is also very, very important. This is way too important to forget because you can use it to apply a lot of simplification or factorizing polynomials, which we'll learn in future episodes. And we're going to call it today. And the next episode, we're going to be looking at other types of this expansion of polynomials. See you around. And I hope you enjoyed and subscribe my 0 subscribes channel. Bye.